November 14, 1965. Landing Zone X-ray. I Drang Valley, Central Highlands of South Vietnam. 10:48 a.m. First Lieutenant James Riley's pen barely moved as he scribbled in his field notebook, his hands still trembling from the firefight that had erupted moments after the helicopters departed. "The rifle in my hands just saved my life," he wrote, "but I watched 3 men die today because theirs would not fire." Through the elephant grass and triple canopy jungle, approximately 14 miles west of Ply Me Camp, American soldiers of the 1st Cavalry Division Air Mobile had just experienced their first major battle against regular North Vietnamese Army forces. 450 men of Lieutenant Colonel Harold Moore's 1st Battalion, 7th Cavalry, had been inserted by helicopter into a clearing at the base of the Chupong Massif. Within minutes of landing, they made contact with elements of the North Vietnamese Army's 66th Regiment. What would become a 3-day battle had begun. The new M16 rifle, rushed into production and shipped to Vietnam with promises of revolutionary firepower, had performed flawlessly for some units. For others, it had failed catastrophically. What none of them knew was that this moment would trigger one of the most devastating equipment failures in American military history, a systematic collapse of trust between soldiers and their primary weapon that would cost hundreds of lives before congressional intervention forced urgent reforms. The mathematics of this tragedy were being written not in battle plans, but in jam rates, powder specifications, and chrome plating decisions that had prioritized cost savings over soldier survival. The crisis had begun not in the jungles of Vietnam, but in the boardrooms of the Pentagon and the production facilities of American defense contractors. The weapon that would become the M16 started its life as the Armalite AR-15, designed in the late 1950s by Eugene Stoner. Born in 1922, Stoner had served as a Marine in the South Pacific during World War II and later worked as a machinist and design engineer. His revolutionary approach to rifle design challenged every assumption about military weapons. The AR-15 was first demonstrated at Fort Benning, Georgia, in May 1957. This lightweight rifle, weighing just 6.37 pounds compared to the M14's 9.2 pounds, fired a small caliber 5.56 mm round at extremely high velocity. The cartridge itself, based on the commercial .223 Remington round, pushed a 55-grain bullet at over 3,000 feet per second.
The changes began with the ammunition. Eugene Stoner had designed the AR-15 to fire cartridges loaded with IMR 4475, a stick powder manufactured by DuPont. This powder produced specific chamber pressures and a cyclic rate of fire around 800 rounds per minute. The combination had been carefully engineered to work with the rifle's direct gas impingement system, where propellant gases were channeled directly back into the bolt carrier to cycle the action. In March 1964, DuPont informed the Army that it could not mass-produce IMR 4475 to meet the demanded specifications and timeline. The powder worked perfectly in small, controlled batches, producing consistent velocities and pressures, but scaling up to produce millions of rounds while maintaining lot-to-lot consistency proved impossible. The extruded stick powder required precise control of temperature, humidity, and cutting processes. Even minor variations between batches could affect chamber pressures and velocities. The Army needed millions of rounds immediately for Vietnam deployment. DuPont could not deliver. The Army needed an alternative immediately. Olin Matthias and Company stepped forward with WC-846, a ball propellant already in use for 7.62 mm NATO ammunition. Ball powder used an entirely different manufacturing process. The nitrocellulose was dissolved in solvents, formed into tiny spheres, and then hardened. This process was faster, more consistent, and much easier to scale up to mass production. A batch of WC-846 could be manufactured in 40 hours compared to 2 weeks for IMR 4475. More importantly, Olin Mathiasson could guarantee delivery of the enormous quantities the Army required. The Army and Olin Mathiasson both understood that WC-846 burned differently than IMR 4475. The ball powder generated higher peak pressures and maintained those pressures longer as the bullet traveled down the barrel. This produced higher port pressures at the gas port location. The increased gas pressure meant more gas was diverted back through the gas tube into the bolt carrier to cycle the action. This increased the violence of the action cycling and raised the cyclic rate of fire from around 800 rounds per minute to between 850 and 1,000 rounds per minute. More critically, WC-846 contained calcium carbonate as a stabilizer and deterrent coating. The calcium carbonate helped control the burn rate of the powder, but left significantly more fouling residue than IMR 4475. In traditional rifle designs with gas piston systems, this increased fouling went into the gas piston and could be cleaned from outside the action. But the M16 used direct gas impingement. Every bit of that calcium carbonate residue was blown directly back into the bolt carrier, the bolt, and, most critically, the chamber itself with every single shot fired. Crucially, no one conducted extensive testing of the M16 with WC-846 ammunition before approving the change. The rifle had been tested and approved with IMR 4475. The ammunition change was treated as a simple substitution rather than a fundamental alteration to the weapon system. Army acceptance tests continued using remaining stocks of IMR 4475 loaded ammunition, even as millions of rounds of WC-846 ammunition were being produced for shipment to Vietnam. The second critical decision involved chrome plating. Eugene Stoner and the Colt engineers who manufactured the rifle strongly recommended chrome plating the chamber and bore. This was not new or experimental technology. Chrome plating had been used in artillery barrels since World War I and in aircraft machine guns throughout World War II. The process involved electroplating a thin layer of chromium onto the steel surface, creating a hard, corrosion-resistant finish. Chrome plating would protect against corrosion in Vietnam's humid jungle environment and would help prevent cartridge cases from sticking in the chamber during extraction. The United States military had extensive experience with tropical corrosion from the Pacific theater of World War II. Weapons that performed flawlessly in temperate climates had corroded rapidly in the humidity of Pacific islands. Chrome plating had been identified as the solution decades earlier. The Army rejected this recommendation. Chrome plating added cost and production time to each rifle. Each chamber had to be carefully prepared, plated in an electroplating bath, and then inspected. The process added several steps to the manufacturing timeline. More importantly, traditionalists in Army ordnance worried that chrome plating would affect accuracy. Some target shooters believed that chrome-plated barrels were less accurate than bare steel, though testing had never confirmed this belief for military-grade accuracy standards. The decision was made to produce rifles without chrome-plated chambers despite warnings from the manufacturer. The Army cited the expense as cost-prohibitive, though no official documentation specifies the exact savings per rifle. Army ordnance believed that proper maintenance would prevent corrosion problems. This belief would prove catastrophically wrong in Vietnam's climate and combat conditions.
The third decision would prove equally catastrophic. Colt had advertised the M16 as requiring minimal maintenance, far less than the M14. This was true when firing ammunition loaded with IMR 4475 in controlled conditions. Marketing materials and some early briefings described the rifle as nearly self-cleaning. The Army took this characterization at face value and failed to provide adequate cleaning equipment or training to troops deploying to Vietnam. Soldiers received their new M16s with virtually no cleaning kits, no instruction on proper maintenance procedures, and often with explicit statements that the rifle required little to no cleaning. Many were told the weapon was self-cleaning and that attempting to clean it improperly might damage it. This guidance would prove lethal when combined with the fouling properties of WC-846 powder and the lack of chrome plating in the chamber. The fourth modification compounded the emerging disaster. The original AR-15 lacked a forward assist, a device to manually ram the bolt fully forward if it failed to close on its own. Eugene Stoner had deliberately omitted this feature, reasoning that if the bolt wouldn't close easily, something was wrong and the soldier should clear the malfunction rather than force it. Army ordnance insisted on adding a forward assist, arguing that soldiers needed the ability to force the rifle into battery. This seemingly minor change would later become a symbol of the systemic problems, soldiers using the forward assist, desperately trying to close bolts on chambers already fouled beyond function. The first M16s arrived in Vietnam in early 1965. Initial issue went to elite units, special forces, airborne, and the 1st Cavalry Division. These early deployments mostly used remaining stocks of IMR 4475 loaded ammunition and included soldiers who received better training and maintained their weapons meticulously. Reports from these units were largely positive. Lieutenant Colonel Harold Moore's 1st Battalion, 7th Cavalry, carried M16s into the Ia Drung Valley in November 1965. Moore, a West Point graduate and combat veteran of the Korean War, commanded 450 men organized into 4 rifle companies. They deployed aboard 16 UH-1D Huey helicopters, landing in waves at Landing Zone X-ray. The landing zone was a clearing approximately 100 yards wide at the eastern base of the Chu Pong Massif, a mountain that rose to 2,400 feet and marked the border with Cambodia. Within 15 minutes of the first helicopter touching down, Moore's troops made contact with North Vietnamese forces. What followed was a desperate 3-day battle against elements of 3 North Vietnamese regiments, perhaps 2,000 enemy soldiers. The fighting was often at point-blank range, sometimes hand-to-hand. North Vietnamese forces launched human wave assaults. American soldiers fired their M16s on full automatic, burning through magazine after magazine. In that first major engagement between American and North Vietnamese regular forces, the M16 performed remarkably well for most soldiers. The rifle's high rate of fire and lightweight ammunition allowed troops to carry significantly more rounds than they could have with M14s. Lieutenant Colonel Moore had ordered his men to carry as much ammunition as possible. Many soldiers carried 300 to 400 rounds. In the desperate close-quarters fighting that characterized Ia Drang, this ammunition capacity proved decisive. American firepower, combined with artillery support and tactical airstrikes, prevented the North Vietnamese from overrunning the landing zone. Sergeant Ernie Savage, who fought in the battle, later described the experience. "I did not run out of ammunition. I had about 30 magazines in my pack and no problems with the M16. Savage's platoon held a critical position on the perimeter throughout the battle. The M16s functioned as designed. But Ia Drung represented the best-case scenario for the M16. These were well-trained soldiers of an elite air-mobile division. They had received better instruction on the new rifle than conventional infantry units would receive later. They maintained their weapons carefully. Most critically, many of the rifles at Ia Drang were still using ammunition loaded with IMR 4475 powder, the propellant the rifle had been designed to use. The weapons were relatively new, with chambers not yet corroded. The chaos of battle and the success of the engagement masked early warning signs of the problems that would emerge months later. As 1966 progressed and hundreds of thousands of M16s flooded into Vietnam, loaded exclusively with WC-846 ammunition and issued to conventional infantry units with minimal training, the crisis began to unfold.
By mid-1966, reports started filtering back from Vietnam that the M16 was failing at catastrophic rates. Soldiers wrote desperate letters home describing rifles that jammed after firing just a few rounds. Officers filed official complaints stating that their men had lost confidence in their primary weapon. Medical evacuation helicopters brought back wounded men who reported their rifles had failed at the moment they needed them most. The failures followed a predictable and deadly pattern. After firing 10 to 20 rounds, especially in full automatic mode, the rifle would fail to extract the spent cartridge case. The sequence of the malfunction became grimly familiar to soldiers throughout Vietnam. The soldier would pull the trigger, the rifle would fire, the action would cycle, the bolt carrier driven backwards by gas pressure. The extractor would attempt to pull the spent cartridge case from the chamber, but the case would stick, gripped by the corroded chamber walls and sealed by powder residue. The extractor, a small hook-shaped piece of spring steel, would pull against the rim of the brass case. The soft brass would deform under the pressure. The extractor would tear through the rim, leaving the body of the cartridge wedged firmly in the chamber. The bolt carrier would cycle backward, ejecting only the torn brass rim. A fresh round would be stripped from the magazine and pushed forward by the bolt. But the bolt could not close. The chamber still contained the body of the previous cartridge case. The fresh round would jam against the stuck case. The action would be completely locked. The soldier would pull the trigger and hear only a click. The hammer had fallen on a firing pin that could not reach the primer because the bolt was not fully closed. At this point, the rifle was completely inoperable. No amount of manipulation of the charging handle or forward assist would clear the malfunction. The only way to clear this type of jam was to insert a cleaning rod down the barrel from the muzzle end and punch the stuck case backward out of the chamber. This required removing the magazine, locking the bolt to the rear, inserting a cleaning rod down the 20-inch barrel, and forcibly driving the stuck case out through the ejection port. But soldiers had not been issued cleaning rods. The rifle had been described as self-cleaning and requiring minimal maintenance. Cleaning kits, when they existed at all, were typically kept at base camps, not carried on patrol. Even if a soldier had been issued a cleaning rod, performing this clearance procedure under fire was virtually impossible. It required using both hands, taking at least 30 seconds even for an experienced soldier, and left the soldier completely unable to defend himself. In a firefight where the enemy might be 10 feet away in thick jungle, 30 seconds without a functioning weapon was a death sentence. Marine Corporal John Stevens wrote home in June 1966, "Out of 40 rounds I fired, my rifle jammed about 10 times. I pack as many grenades as I can, plus a bayonet and K-bar jungle knife, so I'll have something to fight with. If you can, please send me a bore rod and a 1¼ inch paintbrush. I need it. Our rifles are getting a lot of guys killed because they jam so easily." The desperation in such letters reflects a soldier's worst nightmare. Fighting in dense jungle where the enemy could be 5 feet away, where contact happened without warning, where survival depended on immediate, overwhelming firepower, and discovering that your rifle would fire 5 rounds and then become a useless club. In October 1966, the commanding officer of the 1st Battalion, 2nd Infantry, 1st Infantry Division, filed an official report. The new XM16E rifles are experiencing malfunctions to the extent that confidence has been degraded. His battalion had lost men in firefights when their rifles failed. Troops were beginning to pick up enemy AK-47 rifles from dead North Vietnamese soldiers, weapons they knew would fire reliably even when covered in mud. The AK-47 became the M16's devastating counterpoint. Designed in the Soviet Union by Mikhail Kalashnikov and adopted in 1947, the AK used a fundamentally different operating system. The AK employed a long-stroke gas piston. When the rifle fired, propellant gas was tapped from the barrel through a gas port, but instead of being channeled back into the bolt carrier as in the M16, the gas drove a long piston that was physically separate from the bolt carrier. The piston pushed the bolt carrier backwards, then the piston returned forward while the bolt carrier continued cycling. This meant propellant gas and fouling never entered the action. All the combustion residue stayed in the gas tube and piston, completely separate from the bolt and chamber. The AK was also built with loose tolerances that allowed it to function when dirty, wet, or corroded. The bolt had significant clearance inside the receiver. Dirt and debris simply fell out through gaps in the design. The magazine was curved and designed to feed reliably even when dented or dirty. Every part of the weapon prioritized reliability over precision.
Mikhail Kalashnikov had designed the weapon based on his experience as a Soviet tank commander in World War II. He knew that soldiers in combat conditions could not maintain weapons carefully. He designed a rifle that would work regardless of how badly it was treated.
North Vietnamese and Viet Cong fighters maintained their AK-47s poorly, if at all. Weapons were stored in underground caches where they were exposed to water, mud, and humidity for months. They were carried through rivers, dropped in rice paddies, buried when units retreated. Yet the weapons functioned with near-perfect reliability. An AK could be pulled from a muddy stream, the bolt cycled once to clear water from the action, and the weapon would fire. American soldiers began to notice the contrast immediately. "We found AKs that had been buried in mud, dropped in rivers, left in the jungle for weeks," wrote Sergeant William Rodriguez. "We picked them up, pulled the bolt back, and they fired. Our M16s jammed if you looked at them wrong." The contrast became a bitter joke among infantry units. "The enemy has better rifles than we do." The underground market for captured AK-47s flourished. Officially, carrying enemy weapons was prohibited by regulations. American ammunition was not compatible with the AK, and carrying enemy weapons could lead to friendly fire incidents if the soldier was mistaken for the enemy. Unofficially, many squad leaders allowed or even encouraged their men to carry captured AKs. Some soldiers carried both an M16 and an AK, using the American rifle until it jammed, then switching to the Soviet weapon. A functioning AK was better than a jammed M16. Soldiers understood this, even if Army regulations did not. The first official acknowledgement of the crisis came too slowly. Reports of malfunctions reached General William Westmoreland, commander of Military Assistance Command, Vietnam. Westmoreland found himself in an impossible position. He had personally requested 100,000 M16s for Vietnam, praising the rifle as ideal for jungle warfare. He had visited units at Ia Drang shortly after the battle and heard positive reports about the weapon. He believed the rifle was a significant improvement over the M14 for the type of combat American forces faced in Southeast Asia. Yet soldiers under his command were writing home that the M16 was getting them killed. The complaints could not be ignored, but acknowledging the problem meant admitting a massive failure in weapons procurement. In December 1966, the Marine Corps conducted a formal survey of the 2nd Battalion, 9th Marines, after a series of engagements where rifle failures had caused casualties. The battalion had been involved in Operation Prairie, heavy fighting in the demilitarized zone near the North Vietnamese border. The survey was devastating. Approximately 80% of troops surveyed reported experiencing stoppages during combat operations. Many reported their rifles jamming after firing fewer than 10 rounds. Several Marines stated they had been wounded or seen fellow Marines killed because rifles failed during contact with the enemy. Some Marines reported firing only 3 or 4 rounds before experiencing complete weapon failure. The survey documented the types of malfunctions. Failure to extract was by far the most common, accounting for 80% of all stoppages. Failure to feed, where a fresh cartridge would not chamber properly, accounted for most of the remainder. Failure to fire, where the firing pin failed to ignite the primer, was relatively rare. The extraction failures followed the pattern that would become grimly familiar. The rifle would fire several rounds, then a cartridge case would stick in the chamber. The extractor would tear through the rim case, the rifle would be completely jammed. The survey included the most damning evidence yet. The ICORD committee investigation later confirmed that one Marine corporal had been killed while running up and down the line of his squad trying to unjam other Marines' rifles with his cleaning rod. He was the only member of his squad who had managed to obtain a cleaning rod, apparently by trading with another unit. During a firefight, multiple Marines in the squad experienced extraction failures simultaneously. The corporal moved from position to position using his cleaning rod to punch stuck cases out of chambers under fire. He was shot and killed while clearing a jam from another Marine's rifle. His own rifle, functioning properly, was found next to his body. He had died trying to keep his squad in the fight. By early 1967, the stories were reaching the American public. Soldiers' letters home describing rifle failures began appearing in newspapers. One Marine officer wrote to Senator Gaylord Nelson, "The weapon has failed us at crucial moments. As many as 60% of the rifles failed to operate. I know of at least 2 Marines who died within 10 feet of the enemy with jammed rifles." Another letter from a Marine simply stated, "You know what killed most of us? Our own rifles, the M16. Families who had lost sons in Vietnam demanded to know if inadequate equipment had contributed to their deaths. On March 26, 1967, the Washington Daily News broke a major story about M16 reliability problems, featuring interviews with returning soldiers and excerpts from letters sent home from Vietnam. The article created a political firestorm. How could American troops be sent into combat with defective rifles? Why had the problems not been identified and corrected before widespread deployment? Who was responsible for decisions that prioritized cost and production speed over soldier safety? The pressure became impossible for Congress to ignore. On May 3, 1967, Representative L. Mendel Rivers, chairman of the House Committee on Armed Services, established a special subcommittee to investigate the M16 rifle program. Congressman Richard Icord, Democrat of Missouri, was appointed chairman of the subcommittee. He was joined by Representative Speedy O. Long of Louisiana and Representative William G. Bray of Indiana. The Icord Committee, as it became known, would conduct the most thorough investigation of a weapons procurement program in congressional history.
Over the next 5 months, the committee held hearings on May 15th, 16th, and 31st, June 21st, July 25th, 26th, and 27th, and August 8th, 9th, and 22nd. All hearings were conducted at the Rayburn House Office Building in Washington. The committee interviewed hundreds of witnesses: combat soldiers recently returned from Vietnam, Army generals, Colt engineers, ammunition manufacturers, Eugene Stoner himself, and Pentagon procurement officials. Testimony was given under oath. Documents were subpoenaed. Technical experts were brought in to explain the ballistics and engineering involved. The committee examined every aspect of the M16 program. They reviewed procurement decisions going back to 1963. They analyzed test reports that had been filed and ignored. They studied engineering drawings and manufacturing specifications. They interviewed soldiers who had survived firefights where their rifles failed. They brought in weapons that had been recovered from casualties, rifles found next to dead Americans with stuck cases still in the chambers. The picture that emerged was devastating. Every decision that had transformed the reliable AR-15 into the failing M16 was documented in detail. The switch from IMR 4475 to WC 846 powder without adequate testing, the rejection of chrome plating despite manufacturer recommendations, the failure to provide cleaning equipment or training, the misleading claims about the rifle being self-cleaning, the increased cyclic rate that accelerated fouling, the quality control problems at Colt that allowed rifles to be shipped with defective parts. Each failure was documented with technical data, engineering reports, and the testimony of soldiers who had paid the price. The committee discovered that multiple people had raised red flags about these issues before widespread deployment. Colt engineers had protested the ammunition change in writing. Company officials had stated explicitly that they could not guarantee weapon performance with the new powder. Eugene Stoner had recommended chrome plating in his original design specifications and had reiterated this recommendation when the Army began large-scale procurement. Air Force officers who had used the rifle successfully with proper ammunition and maintenance had emphasized the need for cleaning equipment and training. Test reports had shown increased malfunction rates with WC 846 ammunition. All of these warnings had been ignored, dismissed, or buried in the urgency to get rifles to Vietnam and the desire to cut costs. The most damning revelation concerned who knew what and when.
Army Ordnance had test data showing that WC-846 ammunition caused increased malfunction rates. They had reports from Colt stating that the company could not guarantee rifle performance with WC-846. They knew that rifles without chrome plating corroded in humid environments. They knew that soldiers were not receiving adequate training or cleaning equipment, yet deployment had continued month after month while soldiers died because their rifles failed. The testimony of returned combat veterans proved particularly powerful. Marine Corporal Martinez testified about a firefight where his rifle jammed after the third round. He described using his jammed rifle as a club, suffering a bayonet wound, and watching his fire team leader die while trying to clear his own jammed rifle. Private First Class David Chen described finding a dead American patrol. All 7 men killed, all 7 M16s jammed, cleaning rods scattered around the bodies where the men had died trying to clear their weapons. Eugene Stoner explained his design philosophy for the committee. The AR-15 was engineered as a complete weapon system. The rifle, the ammunition, the maintenance procedures all worked together. Changing the ammunition without extensive testing broke the system. He had recommended chrome plating specifically because he knew the direct gas impingement system would be vulnerable to corrosion without it. He had never claimed the rifle was self-cleaning. That characterization had been invented by marketing departments and repeated by people who did not understand the weapon. Ballistics experts testified about the differences between IMR 4475 and WC-846. The ball powder produced higher port pressures that increased the volume of gas and residue blown into the action. The calcium carbonate in WC-846 created fouling that IMR 4475 did not. The increased cyclic rate meant more rounds fired before a soldier could react to a malfunction, leading to worse jams. All of this had been predictable. Some of it had been predicted. The predictions had been ignored. Representatives from Colt testified that they had raised concerns about the ammunition change. They stated in writing that they could not guarantee rifle performance with WC-846 and that the increased cyclic rate violated Army acceptance standards. The Army had granted waivers allowing the higher cyclic rate. Quality control inspectors testified about finding defects in rifles being shipped to Vietnam. Bolt carriers with improper hardness that would crack under stress, extractors with weak springs that would fail to pull stuck cases. They had rejected these rifles. The rejections had been overruled in the urgency to meet production quotas. The financial testimony exposed another dimension of the scandal. The decision to use WC-846 had saved money. Ball powder was cheaper and faster to produce than stick powder. Olden Matheson had made substantial profits from ammunition contracts. The decision not to chrome plate chambers had saved production costs. While the committee found no evidence of outright corruption or bribery, the cozy relationships between military procurement officers and defense contractors had clearly affected decision-making. Cost considerations and production convenience had outweighed combat effectiveness and soldier safety. By August 1967, the ICHARD Committee had assembled an overwhelming case. The M16 failures were not the result of soldier incompetence or inadequate training alone. They were the result of systematic failures in weapons procurement, testing, and deployment.
Multiple officials and organizations shared responsibility. Army Ordnance had approved the ammunition change without adequate testing. The Army Materiel Command had rejected manufacturer recommendations about chromoplating. Training commands had failed to develop proper maintenance instruction. Colt had continued production despite knowing about problems. Olin Matheson had supplied ammunition that did not work properly with the rifle. Pentagon procurement officials had prioritized cost and speed over reliability. The committee's formal report, released on October 19, 1967, contained extensive findings and recommendations. The switch to ball powder ammunition was identified as the primary cause of malfunctions. The lack of chrome plating in the chamber was the secondary cause. The failure to provide adequate cleaning equipment and training was the tertiary cause. The report recommended immediate action. Chrome plate all M16 chambers and bores. Develop improved ammunition with reduced fouling characteristics. Provide extensive cleaning kits to all troops carrying M16s. Implement comprehensive training programs on proper maintenance. Modify the rifle to reduce the cyclic rate. Establish better quality control in production. Create accountability for procurement decisions that affected soldier safety. The investigation generated enough political pressure that the Army could not continue its previous course. Changes began immediately, even before the final report was released. The Army had already begun standardizing the XM16E1 as the M16A1. The XM16E1 was type classified as the M16A1 on February 28, 1967. Production of the improved rifle ramped up rapidly throughout the spring and summer. The M16A1 incorporated critical modifications that addressed every major failure point. The chamber and bore were chrome-plated, eliminating the corrosion problems that caused cases to stick. The chrome plating process added several manufacturing steps but proved essential. Each chamber was carefully prepared, cleaned, and then electroplated with a thin layer of hard chromium. The chrome created a smooth, corrosion-resistant surface. Spent cartridge cases no longer stuck in corroded chambers. Extraction failures dropped dramatically. A new buffer assembly reduced the cyclic rate back toward the original specifications. The buffer consisted of weights and springs inside the buttstock that absorbed the impact of the bolt carrier at the end of its rearward travel. The redesigned buffer used heavier weights and stiffer springs to slow the action cycling. This reduced the cyclic rate from over 900 rounds per minute back down to between 750 and 850 rounds per minute. The slower cyclic rate meant less violent action cycling and reduced stress on all components. Most importantly, the designation change came with a complete overhaul of training and maintenance procedures. The self-cleaning myth was explicitly and publicly debunked. Army training commands rewrote all instruction materials. The new doctrine emphasized that the M16 required regular, thorough cleaning, especially in combat conditions. Field Manual 23-9 was completely rewritten with detailed cleaning instructions. The new manual included step-by-step procedures with photographs and diagrams. It specified exactly how to disassemble the rifle, what to clean, how to clean it, and how often. Soldiers were instructed to clean the chamber and bore after every firing session. The gas tube required cleaning weekly in combat conditions. The bolt and bolt carrier needed to be disassembled, cleaned, and lubricated daily when in the field.
Comic book-style manuals were produced showing soldiers exactly how to maintain their rifles. These manuals, with simple illustrations and step-by-step procedures, could be understood even by troops with limited literacy or for whom English was not their primary language. The comic format used clear drawings showing each step of disassembly and cleaning. Arrows indicated direction of movement. Text was minimal and simple. A soldier who could not read technical prose could follow the illustrated guide. Comprehensive cleaning kits were manufactured and distributed throughout Vietnam. Each kit contained everything needed to maintain the rifle in combat conditions: a 3-piece aluminum cleaning rod that could be screwed together to reach the full length of the barrel, a bore brush with stiff bronze bristles to scrub fouling from the rifling, a chamber brush specifically designed to clean the chamber walls where cases stuck, pipe cleaners to clean the gas tube without disassembling the rifle, cotton patches to wipe surfaces clean, a small bottle of lubricating oil, a toothbrush-style brush for cleaning the bolt and bolt carrier. The entire kit fit in a small plastic case that could be carried in a cargo pocket or attached to load-bearing equipment. Soldiers were required to clean their rifles daily in combat conditions, more often if they had fired extensively.
Squad leaders inspected weapons regularly. Platoon sergeants conducted detailed inspections before and after operations. A dirty rifle was treated as a serious offense, equivalent to other failures of discipline. The message was clear: your rifle will work if you maintain it. It will fail if you neglect it. Most critically, the ammunition itself was improved. In 1970, a new powder designated WC-844 replaced WC-846 for 5.56 mm ammunition. WC-844 had reduced calcium carbonate content, producing significantly less fouling. The combination of chrome plating and cleaner ammunition solved the extraction problem that had killed so many soldiers. The results were dramatic. By late 1967 and early 1968, units equipped with M16A1s, proper cleaning equipment, and adequate training reported substantial improvements in reliability. Malfunction rates dropped to levels comparable to or better than other military rifles. The extraction failures that had plagued the original M16 became rare. Soldiers who had despised and feared the M16 began to trust it. The rifle's inherent advantages could finally be realized without the crippling reliability problems. The lightweight meant soldiers could carry more ammunition or reduce the burden of their combat load. The high-capacity 30-round magazine gave sustained firepower in contact. The controllability in full automatic fire allowed accurate suppressive fire. The devastating terminal ballistics of the high-velocity 5.56 mm round at close range proved highly effective in jungle combat.
With chrome-plated chambers, proper cleaning, and improved ammunition, the M16A1 became the weapon it should have been from the beginning. The transformation was complete. A weapon that had been called a death trap, that soldiers had refused to carry, that men had died cursing, had become trusted and effective. The same basic design, when properly implemented with appropriate ammunition, chrome plating, cleaning equipment, and training, proved to be an excellent combat rifle. The human cost of the delay was incalculable. No one knows exactly how many American soldiers died because their M16s jammed during firefights. The number was certainly in the hundreds, possibly more. Each death was preventable. Each resulted from decisions made in offices thousands of miles from Vietnam, decisions that prioritized production speed and cost savings over soldier survival. The M16 story became one of redemption because the rifle that soldiers called a death trap in 1966 became the rifle they praised in 1970 and beyond. The weapon that symbolized Pentagon incompetence became proof that accountability and transparency could force improvement. But redemption never erases the original sin. The men who died with jammed M16s bought that redemption with their lives. When soldiers were dying with jammed rifles and the military bureaucracy was slow to respond, it took Congress and the press to force action. The I-Cord Committee's investigation saved American lives by exposing the truth and demanding fixes. Today's soldiers carry weapons that work because soldiers in Vietnam carried weapons that failed, and because those failures were not covered up or ignored. The rifle jammed, soldiers died, the news got out, Congress investigated, changes were made, the rifle worked. The M16 failed American soldiers in Vietnam. Then, America fixed the M16. That sequence of failure and correction defines both the tragedy and the triumph of the story. The tragedy was preventable. The triumph was earned. Together, they taught lessons that shaped American military procurement for generations.